So now we're going to be using arrays to organize data. Now an array is an organized list. A table is a very common array. Even a tree diagram, although we'll be dealing with tree diagrams next time. So the first thing that we want to do is create an array to show all the outcomes of Lucinda throwing two six-sided dice and finding the difference between the two numbers. So on one die she can throw a 1 through 6, right? And on the second die, again, 1 through 6. Now what we need to do is find their differences. So, and it doesn't matter which one you're subtracting from the other, we just want to find the difference. So the difference of 1 and 1 is 0, difference of 1, 3 and 1, the difference of 2. You're going to find a pattern really quickly here, right? And then the difference of 2 and 1 is 1, 2 and 2 is 0, 3 and 2 is 1, then 2, 3, and 4. 3 and 1 there's a difference of 2, 3 and 2 is 1, difference of 3 and 3 is 0, difference of 3 and 4 is 1, 2, and 3. Do you see this pattern? Difference of 4 and 1 is 3, 2, 1, 4 and 4 is 0, 4 and 5 is 1 again, and 4 and 6 is 2. So here's the completed array, and I'm going to move that off to the side so I can get more stuff on the screen here. Now the next question is going to ask if, well, to list the sample space, and anytime we list the sample space, of course we get to use the set brackets and then all the possible outcomes. Well, I can see that it's 0 through 5, so I need to list those with a comma. So that's our sample space. Then we're going to are all the outcomes equally likely, and explain. So hopefully you can see already that they're not all equally likely. There are only 2 5s where there are 6 zeros. In fact, there are 10 1s. So we're going to say not equally likely because of that. So how many outcomes, or how many possibilities are in the array? Now that's a different question from how many outcomes there are. Because how many outcomes? There are 1, 2, 3, 4, 5, 6 outcomes, but how many possibilities are in the array? Well, there are 6 rows of 6, so there are 36 possibilities in the array. So next we're going to use the array to help create a probability model, listing the theoretical probabilities for each difference. So a probability model is all the outcomes and their probability. So we need to find the probability of a 0, 1, 2, 3, 4, and 5. Well, we go back to the array and find out how many zeros out of 36. And of course there were 6. Now we don't simplify that fraction in the probability model. So what about 1? We already said that there were 10. So 10 out of 36. How many 2s out of 36? And so forth. Now to make sure the probability model is complete, we should add up all the numerators and make sure that equals 36 out of 36. So 6 and 10 is 16, plus 8 is 24, plus 6 is 30, plus 4 is 34, plus 2 is 36. So we have all of our outcomes and their probabilities. Now from this you can be asked a lot of questions. You know, what's the probability of getting a difference greater than 3? And so we count them all up, and that's 4 and 5, so 4 and plus 2 is 6 out of 36. And of course, since this is our final answer for this probability, we would simplify that to 1/6. And then they might ask us, okay, well, out of 100 throws of the dice, how many times would you expect to get a difference greater than 3? For that, we're going to create a probability, or a proportion. And you can either use 6 over 36 or the 1 over 6. I'm going to use the smaller one, 1 over 6. And that equals how many out of 100? And too bad we can't simply scale this up. So we cross multiply. 100 times 1 is 100. 6 times x is 6x. And then we divide both sides by 6. And 100 divided by 6 is 16.6 repeated. So I would round that to the nearest whole. So I would predict 17 times, 17 rolls, 17 differences greater than 3 out of 100.